thousands of years, humanity has been chasing the same thing: immortality. In Greek mythology, Prince Tithonus was also given a kind of immortality. Eos, the goddess of the dawn, didn't want to lose the man she loved. She wished for eternal life for him from Zeus. But she forgot to wish for one thing: use. Tithonus didn't die, but his body continued to age forever. His hair fell out, his skin wrinkled, his bones grew thin. According to some accounts, he shrank so much that he eventually turned into a cicada. Now, what if I told you that quantum physics promises you this exact curse? Quantum immortality. Sounds quite fascinating, doesn't it? Quantum and immortality. As if there's a scientific way to escape death. But wait a second, this idea might be even darker than death itself. We always explain quantum mechanics from outside the box. You know that famous Schrödinger's cat? In that experiment, we're always an outside observer. We're on the side that finds out if the cat is dead or alive. But in this video, we'll try to look through the cat's eyes this time, because one of the most fundamental questions in the idea of quantum immortality is this: how would the cat experience its own death? Or could it even experience it? Now let me say from the start, there are some obstacles to this idea. The first obstacle is physics. Because first, we need to answer this question: does the universe really allow for such an escape? In other words, does this idea have a counterpart in physics? No matter how strange quantum mechanics seems to us, it works. And it works perfectly. It describes the subatomic world with great precision. In the world we're used to, things are simple. Something has either happened or it hasn't. A choice is made and other possibilities are left behind. At least, that's how we perceive the world. But in quantum mechanics, things get weird. Because here, our issue isn't just whether the cat is dead or alive. There's another question deeper down. Why do we see only a single result when we open the box? The cat turns out to be either dead or alive. But the mathematics of quantum mechanics takes both initial possibilities into account. Does the other possibility really vanish after the measurement? Or do we just see the results on our own side? In 1957, physicist Hugh Everett brought a very radical interpretation to this. Why should we have to choose a single possibility? He asked. This is a very strong objection to the Copenhagen interpretation of quantum physics. But there's no explanation in the math that makes this collapse mandatory. The measurement problem is still being debated even today. And that's exactly why Everett said this collapse isn't mandatory. So if the cat continues to live, does the possibility of being dead disappear? According to Everett, no, it doesn't. At the moment of measurement, reality branches out, just like a fork in the road. The cat is dead on one branch and continues to live on the other. Both are real in their own universe. Of course, it's not that easy for everyone to be convinced by this idea. In fact, harsh objections came from the scientific world. Bryce DeWitt, a prominent physicist of the time, posed this question to Everett: if reality is branching, why don't we ever notice it? Everett responded to this with a very clever question of his own. Do you feel the Earth rotating around the sun at 30 kilometers per second? Just because we don't feel it doesn't mean it's not happening. But here, the subject goes beyond just physics, everyone. Because if both possibilities continue to exist, which side do we end up on? The idea of quantum immortality is born right on this fine line. On one side, there's death. On the other, another branch where life continues. Now let's get to the real big question. What happens when we die? What do we experience? If reality branches out, do we have a chance to experience the branch where death occurs? Or does experience only flow in the branch where life continues? Today, scientifically, death is described as the end of experience rather than something experienced. Because what we call consciousness is only possible with a functioning brain. When the brain stops functioning, consciousness also ends. So there's no one left to experience death. If experience really ends in the death branch, subjectively, only the branch where life continues remains. From the outside, everything's clear. The family mourns, the funeral is held, the body is laid to rest. That person really dies. But from the inside, from the person's own experience, maybe an end never actually happens. Because there's no consciousness left to experience that end. Well, since both branches continue to exist, why don't they ever interact? Why do our dying version and our living version never meet? In physics, this is called decoherence. After branching, these two realities practically separate from each other. Each proceeds independently on its own path. You can think of this like fine ripple patterns in a calm lake. If the water's still, you see those delicate rings clearly. But when the surface is disturbed by wind, that regular pattern is no longer discernible. Something similar happens in the quantum world. Countless interactions with the environment break that delicate connection. So even if the branches theoretically start at the same point, in practice they proceed without mixing. So the cat in the box continues to breathe in one branch. In the other branch, there is silence. But these two branches no longer share any information. The living version of the cat doesn't encounter its own absence in the death branch. For the cat, there's only the branch where it's breathing. From outside the box, there is death. But from the cat's perspective, experience only seems to flow in the branch where life continues. So there's your formula for immortality. No need to find an elixir or anything like that. Maybe, from a subjective standpoint, an end called death is never actually experienced. But there's also a dark side to this idea, because it's not just about not dying. How you continue also matters. And here the second obstacle comes in. The body. Because death doesn't always happen instantly, like pressing a button. I mean, we don't necessarily have to die in an accident or from a sudden blow. There's illness, there's old age, there's severe brain damage. Well, you'll say our consciousness is already interrupted many times throughout our lives. And that's a valid objection. We sleep, we faint, we undergo anesthesia. Yes, consciousness is interrupted in those moments, but there's a huge difference. In sleep or under anesthesia, the brain system is still working. It just switches to a different mode. In severe damage, memory can be erased, thoughts can scatter, personality can change. So if quantum immortality always saves us from an accident, why can't it save us from aging? Because they're not the same thing. Surviving a car accident is an instantaneous event. It happens in a moment and gives a result in a moment. But stopping aging requires countless biological processes to reverse at the same time. Cells, tissues, brain, immune system, memory, all must be preserved simultaneously. But the idea of quantum immortality doesn't promise you that. You think you've escaped death, but you just get stuck inside a slowly dissolving body, like an insect trapped in its shell. Quantum immortality takes this oldest fear of humanity and turns it into a modern thought experiment. Immortality, the thing we've pursued and desired for thousands of years, can turn into a curse. For example, imagine living forever after permanent brain damage. Can that really be called living? Maybe the medicine of the future can fix such damage one day. We don't know. But quantum immortality itself doesn't promise you that. It doesn't offer you a healthy body. It doesn't give back youth. It only says this: the end might never fully arrive. And that's what's truly terrifying. All right, we've somehow passed the physics and body obstacles. This time we face an obstacle like this. Witnessing. Let's say you really continued living on one branch. Well, who will know? Who will verify it? From the outside, you're dead. Your loved ones mourn. Your name is written on a tombstone. Your life ended in the world of others. But from your perspective, the experience continues to flow on another branch, as if you crossed a threshold, but there's no one who crossed that threshold with you. You can't go back and prove it, nor can anyone else witness it. Then this question becomes inevitable. How real can we call something that only continues for you? There's an even more disturbing side to it. Remember we said two branches, one for life and one for death? Well, is the person waking up on the branch where life continues really you? Quantum physics can offer us a strong framework for how the universe might branch out. But it can't tell you on its own whether the person living on that new branch is really you. And that's exactly where the biggest hurdle begins. The problem of the self, maybe the real threshold, isn't the line between life and death. It's the line between being the same person and not.
Scotty, beam us up fast.
Think about the teleportation scene in Star Trek. The machine scans you down to your atoms and recreates you in another location. Okay, but what if the machine makes a mistake? What if another copy of you appears before you're gone? The person in front of you knows all your memories, talks just like you, and thinks just like you. They look at you and say, I'm the real me. So then, which one of them are you? If both copies can say, I am me at the same time, how do we define the real self? By memories? By the body? Or by the sense of continuity? At this point, the question changes. What if the survivor isn't us, but someone else carrying our memories? At this point, quantum immortality shifts from a physics idea to a question of self. Because in daily life, we accept what we call me very easily. We wake up, look in the mirror, and don't doubt that the person we see is us. Because we don't see a stranger, but the continuation of yesterday's life. There's an unbreakable bond between the person who felt, thought, and remembered yesterday and the one in the mirror today. But how exactly do we describe this bond? This is one of the major questions in philosophy. Is something whose parts have changed still the same thing? For example, if a ship's rotten planks are replaced one by one, is it still the same ship in the end? This question gets even weirder for the cat in the box. Is the cat that dies on one branch and lives on another really the same cat that entered the box? When it comes to humans, the situation becomes even more complex, because a human isn't just made of a body. There's memory, consciousness, and the sense of self involved. After all, our cells change too. Our memories fade, and our bodies transform every single second. Yet a sense of continuity still remains within us. The idea of quantum immortality relies somewhat on this feeling, because it's not just about life continuing somewhere, but about that life feeling like it's continuing uninterrupted from the inside. Thinkers like British philosopher Derek Parfit open an important door here. According to Parfit, personal identity might not be as deep or unchanging as we think. Maybe what really matters isn't being exactly the same person, but the feeling that the story continues uninterrupted from an internal perspective. Proponents of quantum immortality look at it from this very angle. That is, not from outside the box, but through the cat's eyes. If a consciousness feels like its own story is continuing without interruption, can we even speak of death? This thought is very appealing to humans, because immortality is such a great consolation. We want to believe that something continues somewhere. We want to believe the story isn't over, that even if the curtain falls, the light hasn't gone out somewhere inside. But let's hit the brakes a bit here, because life continuing somewhere and that life being a continuation of you are not the same thing. Physics might leave some possibilities open, but it can't tell you which of those possibilities is actually you. It seems to me that what makes quantum immortality so fascinating is the meaning we give it more than physics itself. The story might continue somewhere, but is the person living it really the same person? That's why Everett's many worlds interpretation alone doesn't prove quantum immortality. Well, we're always talking about immortality, but is it really a good thing? Maybe a real fear isn't ceasing to exist. It's slowly diminishing within our own story. It's that wholeness we call I slowly slipping away from us. But still, this idea doesn't leave you alone, because ceasing to exist isn't something the mind can easily accept. The mind is always looking for a door, chasing a possibility. Quantum immortality might not offer proof, but it says what we want to hear. That's partly what draws us to it. It looks like a scientific theory, but it touches a very old, very human wound. The fear of ceasing to exist. And sometimes ideas become powerful not because they're true, but because they're bearable. Hugh Everett died at 51. When his daughter Elizabeth passed away years later, the note she left behind said this: "I hope we meet again in a parallel universe one day." This shows us something very human. Even in their deepest pain, a person clings to a consolation, a possibility. They want to believe that a door hasn't fully closed. But why? Why do we need such a consolation? Maybe we always see death as something dark, standing opposite life. We think that when something ends, its value disappears. But does a story have to last forever to be valuable? Or let's ask it the other way around. If no story ever really ends, does the weight of that story remain the same? Now let's return to the box once more. We were looking through the eyes of Schrödinger's cat, remember? That cat is dead in one branch, alive in the other. But even when the box is open, the main question isn't answered. Is the one that continues to live really the same cat? Or is it just another consciousness carrying its body and emotions? Tithonus' story is actually a bit like this too. He didn't die either. But when he turned into a cicada, was he still the same Tithonus? He was making a sound, but did that sound still belong to him? Is what makes a life valuable the fact that it never ends? Or is it existing within it while knowing it's temporary? Maybe the answer is hidden right here. To truly live for the first time, despite the existence of death, or perhaps even because of it.